In this question, they are saying there are two automobiles that are 150 kilometers apart and they are traveling towards each other. One is moving at 60 kilometers per hour and the other is 40. In how many hours will they meet? So let's say we have one here and that is moving at 60 kilometers per hour, and then there's another one and towards each other, so they are moving towards each other and meeting somewhere in between. So let's say they are meeting here. In how many hours will they meet? So they are 150 kilometers apart, which means if there's a d distance between the first one and where they meet, then it's going to be 150 minus d for the one that is moving at 40 kilometers per hour, because when you add the two it has to be 150. So we are also looking at time, right? So when would they meet? Let's say the 60 kilometers per hour car takes time t1 to meet. So how much time does the 40 kilometers per hour car take? If you think about it, they take the same time because they are meeting at the same position and they left at the same time. So let's say you and a friend are leaving at points A and B and you are meeting in between. And if you both left at 11 o'clock and if you meet each other at 11:45, that means no matter how much speeds each of you had, each of you took 45 minutes to meet. So that means we have t1 time from the 60 kilometers per hour start position and the meet. It takes the same amount of time for the 40 kilometers an hour vehicle to meet at the same time. So given this information, remember that we have t, which is time, is equal to displacement divided by V average. So let's do this for each vehicle. So for the first one, you have t1, which gives us a d distance because it traveled a d displacement, and then the average is 60. And for the second one, we have same t1, we have the displacement of 150 minus d divided by 40 kilometers per hour. And as we discussed earlier, these two times are the same, so we can equal them to each other. So we have d over 60 equals 150 minus d over 40. So let's just cross multiply, which gives us 40 times d equals 60 times 150 minus d. So we have 40d equals 60 times 150, which is 9,000, then minus 60d. So if we take the minus 60 to the left hand side, we have 100d equals 9,000, and that gives us d equals 9,000 divided by 100, which is 90 kilometers. So now we know the distance d, which is the distance that the 60 kilometers per hour vehicle travels before they meet. Now we can plug in this d value to either one of the equations. So let's just plug it into this equation right here. So we have t equals d, which is 90 kilometers, divided by 60, and remember this is 60 kilometers per hour. So that gives us t equals 1.5 hours. You see that the kilometers cancel in this equation.